All the wastewater flow generated within SAM's service area is processed through the wastewater treatment plant. The influent flow rate is measured at the influent flow meter, also known as a partial flume. Measuring flow rates and tracking flow rate trends helps SAM adjust plant operations for greatest efficiency and service. The mechanical bar screens provide the first step of treatment by removing trash and solid debris from the incoming wastewater. Any debris larger than the half-inch screen openings is captured, removed with an automatic rake mechanism, and deposited into a waste bin. Twice a week, the waste bin is emptied and the solid debris is transferred to a local landfill. The influent pump station is home to 8 solids handling centrifugal pumps, capable of pumping all the wastewater that flows into the treatment plant. These powerful pumps lift the incoming flow 20 vertical feet so that the wastewater can flow by gravity throughout the rest of the treatment plant.
The grit chambers consist of 2 aerated tanks that circulate wastewater and allow grit particles to settle to the bottom by gravity, where they can be more easily removed. Grit includes heavy particles such as sand, coffee grounds, and other small particles that cannot be removed by the mechanical bar screens. The primary clarifiers are long rectangular tanks where the wastewater is allowed to slow down for gravity to take over. This step removes heavy sediment, such as soil particles, that are too fine for the bar screen or grit chamber to remove. These heavy sediments, also called sludge, sink to the bottom of the tanks and are mechanically removed by scrapers. At the same time, lighter solids such as fats, oils, and grease rise to the top, where they are skimmed off and discarded to the landfill.
The aeration basins are where the biological treatment of wastewater happens, which is one of the most critical steps of the wastewater treatment process. Over 1,000 fine bubble diffusers are installed on the floor of the basins, releasing thousands of cubic feet of dissolved oxygen into the wastewater stream. The oxygen-rich air is consumed by the aerobic microorganisms in the wastewater during its time in the aeration basin. Microorganisms use the oxygen for respiration as they feed on the nutrient-rich wastewater and naturally break down organic wastes into carbon dioxide. Once the wastewater leaves the aeration basins, it flows to the secondary clarifiers and is allowed to settle once again. The secondary clarifiers are circular structures, 85 feet in diameter and 14 feet deep. Similar to the primary clarifier, the secondary clarifiers have a large surface area that allows the flow to slow down so that settling can occur naturally. Sludge sinks to the bottom of the clarifiers and lighter particles float to the top, where they are removed by mechanical scrapers.
After the physical and biological processes of treating wastewater, the final stage is the chemical process of disinfection. The SAM plant uses 2 main chemicals. Both can be found in the chemical storage facility. These 2 chemicals are equally important to the wastewater treatment processes. The first is sodium hypochlorite, which is used to chlorinate and disinfect the treated wastewater. The second is sodium bisulfite, which is used to dechlorinate the wastewater before it's discharged into the Pacific Ocean. Sodium hypochlorite, similar to bleach, is added to the wastewater to disinfect germs, bacteria, and viruses as it flows through the chlorine contact tanks. Finally, the fully treated wastewater passes through the effluent pump station. SAM also recycles some of the treated wastewater back into the plant and uses it in a variety of treatment processes to reduce the use of potable water. This non-potable water is referred to as number 3 water. 3 vertical turbine pumps are responsible for making sure the treated flow leaves the plant and travels safely to the outfall pipeline for discharge into the Pacific Ocean. The wastewater is dechlorinated with sodium bisulfite before being discharged through the ocean outfall, a 20-inch diameter pipe 50 feet underwater and 3,000 feet away from land. Protecting the marine environment is a top priority for SAM.
Sludge that is removed from the treatment process in the secondary clarifier is dewatered in a rotary drum thickener, which slowly rotates while liquid drains out. This processed sludge then moves to the anaerobic digesters. The sludge and scum from the primary and secondary clarifiers is pumped to the anaerobic digesters to feed anaerobic microorganisms. The anaerobic microorganisms here prefer an oxygen-free, heated environment while they break down biodegradable solids and kill harmful pathogens in heated digester tanks. The digestion process kills harmful pathogens and reduces the volume of organic solids. One of the byproducts of this process is methane, also called biogas, which can be used to generate electricity for use at the wastewater treatment plant and beyond. The biogas is also burned to generate heat for keeping the digesters warm, which promotes the biological process. Boilers are heated to 95.3 degrees Fahrenheit with the biogas generated in the digester. The heat exchanger allows heated boiler water and digester sludge to pass through, heating sludge to 95.3 degrees Fahrenheit. Final treatment of the solids collected from wastewater is achieved with the belt filter press. Fully processed sludge from the anaerobic digesters is now squeezed between perforated conveyor belts and large rollers to remove excess water. The resulting product is a dried cake of biosolids that can be reused at certain compost facilities.
The electrical room houses the treatment plant's motor control centers, also known as MCCs. The MCCs control all of the treatment plant equipment, such as pumps, motors, lights, and critical control systems. To ensure uninterrupted service to the community, SAM maintains an on-site diesel engine-driven emergency generator. In the event of a power failure, the generator will turn on and produce enough electricity to power all of the essential treatment processes. These 4 125 horsepower turbo blowers provide aeration to the secondary treatment of wastewater. This is the heart of the entire wastewater treatment plant. These turbo blowers must run constantly to ensure that the microorganisms in the aeration basins remain alive and healthy.